Alrighty, so today we're going to be looking at something called smoothing. In particular, what we call the 3-point moving mean, and we're going to be doing it by hand. Now, the basic idea behind smoothing is that sometimes our data gets a little bit rough. So sometimes it's easier if we can kind of smooth away the edges. If we've got something that looks like, this, when we smooth it, maybe it might be a little more smooth. So we're just trying to get rid of all of the noise and really see, is there a clearer trend underlying all of this stuff? And one way of doing that is basically by saying, well, if we take a broader range, rather than just looking at 1878 by itself, what if we looked at these 3 years together? Can we kind of get an idea from those 3 years together, what's the behavior that's happening around that time? Now, the basic idea is that what we want to do is average the migration data. And because it's the 3-point, it means that we're doing it with 3 numbers. If we did the 5-point moving mean, we would take 1, 2, 3, 4, 5 numbers into it. But the idea is that we're going to take the first 3 numbers, add them up, divide it by 3 to work out the mean, or the average, of those 3 numbers. Now that's going to give us a new number. And then what we're going to do is we're going to repeat that process for the next 3 numbers. All right, add them up, divide it by 3, so on and so forth. Then we're going to take the next 3 numbers. And we're going to take the next 3 numbers. But you'll notice there's a few things that will happen, and we'll sort of see it at the edges. First thing we should note is that when I average 29, 35, and 85, well, which year is that most associated with? Well, 1879, because really it's 1879 plus its 2 neighbours. Which means we're never going to do a 3-point moving mean for 1878, right? Because it's only got one number to the right. There's no number to the left. So 1878 is going to miss out. Now I'm going to do this as a big column table, so you can see I've already redrawn the table. Give myself plenty of room to write my working out in here. But the first thing I'm going to do is I'm going to say, well, sorry, 1778, there's not going to be anything in there. And the reason for that is that there aren't 3 numbers to choose from. There's only 2, because there is no number here. However, for 1879, it's going to be perfectly fine. We're going to be using these 3 numbers. It's going to be 29 plus 35 plus 85 divided by 3, which is going to be equal to, now we ran into a first problem, 49.6666 ... and there's 7 at the end, but not really. Fortunately, it does tell us to round to 1 decimal place. So let's get rid of all of those 6's and round it up to 7. Alrighty, so now let's repeat it with the next one. So we've got 35, 85, and 210. So 35 plus 85 plus 210. Divide that by 3. And we get 110 exactly. Okay, next one. 85 plus 210 plus 251 divided by 3 equals 182. And I'm just going to keep repeating, going down this, doing this many, many, many times. Alrighty, so we've just finished 1887, and now we get up to 1888, and we run into the same problem we had before. Right at the start, there's a number above it, but there's no number below it. This is the last one. And so with the 3-point moving mean, you always end up with this situation where the first and the last number are never going to be there. They're always going to sort of have disappeared. Alrighty, I've now just summarized the results of this into a table, and now I want to have a look at completing part B, which is to plot it as a graph. Right, so the smoothing process takes a little bit of time, but that's just to basically get a smoother set of data to plot against our original data. So we're going to be plotting 2 sets of data on the same axes. Alrighty, so I've set up my axes. You can see I've gone up in 25s on one axis. Sorry. Alrighty, so for my x-axis, I went up in just years, but I've only written every second year just so that I don't have to write so many. You can see they're all even ones. And then on my y-axis for migration, I've gone up in 25s, but again, I've only written every second one. So you're just seeing the 50 markers of the numbers, but those inner dashes are the 25 markers. It means that you can still get the same accuracy as you would have gotten, just means it's a little bit easier to do. Now, because I'm going to be drawing two different lines, I need to actually explain that on my picture. So this is my raw data, and then in blue, I'll do my smoothed data, or my 3-point moving mean. It's a really common way of actually smoothing data because it gives you a better idea of trend overall. So let's start plotting my original data. So we've got 1878.29, then 35, then 85, and now I'll just finish doing all of the points. Alrighty, so it does take a bit of time to plot, but it's really important that you do take it nice and slow. Now notice what I'm about to start doing is plotting my 3-point moving mean, my smoothed data. And you'll notice that I'm not going to plot anything for 1878. I'm actually going to start at 1879, which is going to be about a 50 mark, which is here. So you can see that I just skipped that first point. There is going to be nothing there. And similarly, there's going to be nothing at 1888. So my smoothed line is actually going to be shorter than my original line because it is not going to have a start or an end point. It's going to start one end. So my next point is 1880, and that goes with 110. And we can continue going through. 1881 is 182. For 1882, it's 220-ish. And so each of these points from 1879 up to 1887 is going to have 2 points at the same vertical point. It's a good way of knowing you've done it all right. Anyway, I'm just going to finish this up off camera. Alrighty, so like I said before, you can kind of see that it doesn't really go through. Now, it does actually ask about the trend. Like, is there really a trend? Well, it went up and then it went down. So we kind of can see that there's this overall pattern happening, but it's not really a positive nor a negative trend. It's kind of a flat trend, really, because all of its gains have gone away. And you can see that in the smooth data in particular, you can really see that it is just this kind of thing. If you remember in grade 10, you would have looked at quadratics. It kind of looks like a quadratic. It's gone up and then down. The original data is a little bit jankier than that. Looks like maybe it's coming back up. But if you look at the smooth data, you can really see that there's no clear trend. There's clearly a peak somewhere around, well, in fact, we can know exactly when the trend was. It was at 1882, and then it's kind of just dropped down since then. But you can still kind of see the main idea of this process, which is that the data, the smoothed data, is less extreme than the original. Sometimes when looking at raw data, you're not going to get a very strong trend at all. But when you smooth the data, you're going to see a clearer picture of what's going on. During the coronavirus, we actually saw that we were often using 7-day moving averages, basically seeing, okay, well, over the last week, what has the behavior of the virus been and the trend patterns. But that was mostly during 2020 and 2021 when we were really interested in how the virus was spreading. And we would use 7-day averages to kind of decide what health policies we should be using. And it sort of gets rid of those really extreme days and those really low days. It kind of shows overall what's going on. Like on weekends, maybe more people get tested so that they go along and then they become a number. But then during the weekdays, they want to go to work because they want the money. So you can just kind of smooth out all of that human behavior into what's actually going on. Alrighty, so that's the 3-point moving mean. It's not very hard. It does take a bit of time, especially if you've got large data points, but if you take it slowly and steady, you can all do it. I know. I'll see you in the next one. Goodbye.